Hi. Today the main topic is the OS scheduling. So yesterday I also talked about OS scheduling, like FC, FS, and those kind of thing. But let me try to talk about like the perspective of this kind of process thing and scheduling thing. Like we say, there's like concurrent thing, but so what do you mean concurrent in C, like those kind of computer architecture or operating system? What I believe of the concurrency or concurrent means that there's no kind of definite concurrent thing even in this computer science world. The example, there, if you're trying to look at the like F1, the car race, one car and other car, they seems like entering at the same time, but there should be slight difference of it, like even 0.000 milliseconds of it. And so if you look at this kind of perspective, there's no definite concurrent thing in this world. But how is this really possible in the computer science world? But I think it's not possible. The computer science world, the process doing same concurrent thing seems like it, because the scheduling is really fast, it is really rapid, and then we think that that is the concurrent thing. But why does it make it sense? Because if you look at the computer architecture world, you will understand that the CPU can only execute one instruction and per time. There's a fetch and decode and execute cycle. And every single time of that, the execute thing is one instruction per time. So it can't do some kind of like two instruction and like doing same time. There's no such thing about it. But if you look in operating system, it's kind of abstract software that doing everything rather than we directly communicates with the hardware. So operating system, what I believe is, it's just like kind of abstractions of computer architecture. And the scheduling thing is that there's a process and there's another process. The process has to be handled based on the priority or based on the interactivity. Example, the UI thing has to be there should be no latency of it. So in the UI thing, the round robin has to be done, because round robin, what it does is it just is doing time slicing, and based on time slice, it just makes all the process ends in the same burst time. And the FCFS is basically, okay, I don't care which burst time that you have, we're just gonna treat you as a first when you first enter. It's just like queue of it. And those kind of like scheduling the box of it is actually queue. The scheduling algorithm is basically using queue of it. There's no stuff of the scheduling thing. If you look at scheduler, it's always queue. There is a purge queue on it. And if you look at the batch process, it's using FS. And it's really, if you look at it, everything, the data structure, even like queue is really simple data structure in if you look at the computer science, and is really using in globally. Even the operating system with the computer architecture. If you look at the x86, there's gonna be like prefetch queue on it. So to back again, we talk about concurrency and we talk about scheduling thing, and the data structure is big that used in scheduling algorithm. A round robin is the one who time slice and make sure that all of the queue, all of the process, all of the task doing has same time on the based on the time slice. But the bad thing about this is there's no priority. If it is look at the real time system, the priority has to be done because there's no if there's no priority, there could be a race condition, which is also means that there is constancy. And so there's such a thing as the real time scheduling algorithm, which is MRQ and LLFQ. In order, my professor gave a test about like the philosophy dining problem, and there's like 4 philosophers, and they have some kind of, they're trying to eat something the dining table, and there's gonna be like deadlock on it. There's gonna be like deadlock issue of it because they trying to doing same time. There's like concurrency issue of it because if the one process trying to get the other shared resources, if another resources process can already get the shared resources, and there could be some kind of lot of issue of it. So there's kind of a lot is going to happen. But my perspective on those kind of thing is that why do we even use those kind of thing? Why don't we use kind of real-time scheduler that prevents those kind of like those kind of like data data race the race condition issue? I think yeah. And so in the perspective of OS scheduling, I think it's gonna be really used in the web development. So because what I'm trying to, my plan is that there's like virtual DOM of it. So since virtual DOM requires some kind of tree data structure, and when you're trying to already made the origin DOM and it change the record the DOM, right? That's what also called the virtual DOM. Virtual DOM is just the representation of the object of the DOM structure. But if the other task is being handled before the virtual DOM reconciliation task, there's gonna be issue of it. But because this has to be done quickly, so my question is there's such as web API which is called recursive ID callback. I think I'm just gonna use recursive ID callback to use virtual DOM and using this kind of OS scheduling to make sure that this virtual DOM has to be done quickly rather than slow. So I think this is my plan. So this is, have a nice day. See you next time. Bye bye.